Hi, good afternoon. I'm the replacement for your coffee break, so hope you find it as relaxing as the coffee you're going to drink. My title is Revolutionizing the Way Things Are Made. Now, just a little bit of background before I joined Stratasys. I was a consultant and an accountant with one of the big consultancy firms. So it wasn't often in my 17-year career I got to give presentations about revolutionizing the way things are made. And that's why I bit the bug with Stratasys and joined the 3D printing world. What I want to do is bring home to you, the audience, how 3D printing is today already seriously impacting the way we look at products and use products. And I want to open up our minds as to how it's going to evolve in the coming years. This is really a revolution. It's not 1, 2, or 3 years away. The revolution is here already. These products you see on the page are all in some ways manufactured or designed with 3D printing. So everything you do every day is already being touched by 3D printing. But let's look a little bit further and understand the full scope and potential of 3D printing across a wide variety of industries. And I'm going to put one limitation at the end. There's one societal challenge that we as a society need to deal with if we're really going to get the value out of 3D printing, and it relates to education. And I'll talk about it as we head through the presentation. So you've all heard about the buzzword of Industry 4.0 or the Industrial Revolution. Just as one little example, this is a retail store. Unbelievably, it's a retail store in downtown Manhattan. The concept that they had, and this is called normal, is that the earphones people use on a day-to-day basis when you go running don't fit your ear. Fundamentally, many people, you see them running in the park, the ear falls out. So they've developed a system whereby you give a picture of your ear and they print, using our 3D printers, your specific headphone, earphone to fit your ear. It takes 2 days to receive it by post. All you do is you send a picture of your ear and a check. But it's an example of the fact that industry across all sectors is moving in 2 ways. Number one, it's producing what customers need and want, not what the mass world needs. And secondly, there's a freedom from traditional constraints. If you're a small entrepreneur, you can produce and you can manufacture and you can design. You're not dependent on supply chains stretching across the world to deliver your products after weeks and weeks of waiting. You can iterate, you can design, you can do things without the fixed cost of traditional manufacturing. Now, the role of 3D printing is confusing. Some people say it as hype. Some people say we're pre-hype. Some people say we're post-hype. What is the real story? And this chart is designed to show 3 things. There are 3 broad uses for 3D printing. Prototyping, the way we design and make things, where many people feel or think we've reached a certain degree of maturity along the hype curve of traditional industries. The reality is, and especially for small, medium businesses, prototyping today is currently about 23% penetrated by 3D printing. Small, medium businesses are still relying on weeks-long supply chains to prototype products. And you know what that means for this time to market and the ability to iterate. Then there's manufacture tooling. One of my colleagues was at an automotive manufacturer the other day, a high-end manufacturer, who's already using 600 individual tools in their manufacturing supply chain to produce the tools they use to make the cars. 600, printed on ours and others' printers. But it's there, it's real. And the third is end-use parts, the actual parts that you use, like the earphone, but much broader. Aircraft, I'll show you an example. So 3D printing is in different stages of maturity in different parts of applications in the industry. And it's important we understand there's a nuance to 3D printing. It's truly revolutionizing the way things are made across an enormous spectrum of industries. And it hasn't reached the maturity in all of them, and some it is mature. Just one number. When asked how big will 3D printing be, there are surveys galore. I used to be a consultant, and my job was to produce surveys to some extent. But when you think about, this is a McKinsey survey, 3D printing could generate economic impact of $230 to $550 billion a year within 9 years. What does that mean? That means across different industries, specific consumer product types, assuming 5 to 10% utilization of 3D printing, direct product manufacturing, 30 to 50%, tool and mold manufacturing, 30 to 50%. If there is adoption in specific applications across these industries, that's the sort of quantum size that 3D printing can bring. And the great thing is one of the last speakers spoke about democratization. This is in the realm of everybody to achieve, because the traditional way of manufacturing, there are new ways of doing things today. And it's very important that people can have the tools to make things in the way they didn't previously make them. I want to give you 3 examples, maybe 4 actually, of how this is practically being used today, but I want you to think more boldly about what this means for tens of thousands of other businesses and societies. You've probably heard of Otterbox. Otterbox is the largest manufacturer of smartphone cases in the US. It won't take a genius to know how iteratively and how rapidly that industry has to react to changes. Every day there's a new smartphone. Every day there's a new market wish for a different type of smartphone case. So the ability to produce fast design iterations, not send something to be injection molded and wait 8 weeks to get it back, but the ability in the same day to say, I want to see what this design looks like, to produce it in a way that's a realistic prototype. So I'll give you one example. This is printed on one of our new printers, the J750. This is an example of a prototype printed within just a few hours. Now, it's not a smartphone case, as you can see, okay? And time to market. These businesses live or die on their ability to react to the market quickly. 3D printing unleashes that technology across the prototyping world. And this was traditionally, Otterbox, it would be a 26-week product development cycle, reduced to 8 weeks. And they could produce 5 prototypes a day in an 8-hour day. Second example, and I'm going to show a video to demonstrate how global I am. I'm here in Barcelona. I'm going to show a video. I'm speaking in English, and I'm going to show a video in German with English subtitles. I want to explain a case study of Opel. Opel are producing a new car, the Adam. Now, to do that, anyone that's toured the production line of a car manufacturer knows that there are thousands of tools, jigs, and fixtures in the production line manufactured to enable workers to fit product or fit parts to the cars. It's a core part of the production line. Now, 3D printing brings some massive benefits. You can customize the tool. You can engage the workers in the customization of the tool so that they, again, these are people, these are employees who are fitting thousands of repetitive parts a day. The ability to be part of the design of the way they do it is a huge advantage to the way people do work. The ability to reduce cost by doing it quickly, as needed, and in plastic, not necessarily in metal, is very advantageous. And I want to show you the video to let them speak for themselves. And then I want your minds to think about how many other applications there are of a similar nature across different industries. So can you play the video, please? With the sound.
Die Nutzung von 3D-gedruckten Werkzeugen der Firma IN3DUSTRY gibt uns die Möglichkeit, den Mitarbeiter an der Linie in den Entwicklungsprozess mit einzubeziehen, dadurch, dass er sich die Konzepte, Designs anschauen kann und seinen Erfahrungsschatz mit in das Produkt einfließen lassen kann.
Durch die Anwendung von 3D-Druck sind wir in der Lage, die Entwicklungszeiten für neue Werkzeuge extrem zu verkürzen. In der frühen Prototypphase eines Fahrzeuges können wir innerhalb eines Tages ein Werkzeug neu konstruieren, über Nacht ausdrucken, sodass es am nächsten Tag schon für die Werker zur Verfügung steht. Durch die Anwendung von 3D-Druck haben wir nicht nur erhebliche Zeitersparnis, sondern auch erhebliche Kostenersparnis. Bei den Fertigungshilfsmitteln sind wir in der Lage, zwischen 10 sogar bis zu 90% Kosteneinsparungen zu erzielen.
Okay. He said it much better than me, even if I needed the subtitles to understand it. Third example, end-use parts. What do we mean by end-use parts? Most of you, certainly today and in the next few years, every time you board an aircraft, the chances are that there are parts on that plane which are using end-use produced parts in 3D printing world. Because the huge advantage of 3D printing is complexity doesn't matter. Complexity doesn't cost. It doesn't matter to the technology how complex a part is. So here's an example with Airbus, their new jet, their new A350WXB. They had a very, very short time to deliver to their first customer. Specific parts, the specific plane, but they were dependent on a very difficult supply chain to get those parts. So they were able to take 1,000 parts, non-flight critical, ducting and other parts of the plane, and able to produce them using ultra-grade thermoplastic material, which was certified by the aircraft industry to massively reduce their time to market. There are other advantages as well. If you hold a 3D printed part anywhere around here, you'll notice that the structure weighs a lot less. There's a massive weight reduction because the inside doesn't need to be filled full of material. Okay? So the ability to reduce weight, to improve supply chain flexibility, to improve the ratios that they use in the aircraft industry is very powerful. One example. Two more quick examples, and then I'll wrap up with the challenges we face adopting 3D printing. This is Mia Gonzalez. On the first day, yesterday there was a healthcare session. But Mia is a 5-year-old in Miami who had what was a double aortic arch structural defect in her heart. The doctors didn't know how to operate on her because she had a very complex, looking at the CT scan, heart structure. So they were not sure how to operate on her. Taking the CT scan, they were able to produce an accurate, real 3D print of her heart. And if you listen to the surgeon's quote, I'll read from the screen, "My team could visualize the operation before we started. We knew the safest approach and confidently made a smaller incision. I've seen surgeons get lost doing rare operations like Mia's. The 3D model allowed me to proceed through Mia's operation with confidence because I knew her unique anatomy perfectly." Medical is a huge world of customized products. We're all different. The ability of surgeons to actually see the part of the body they're operating on in real life and to practice on it using some of the new materials that have been developed is a massive advantage. And again, I'm not here just to talk about the benefits to the medical industry, but this application has much broader ramifications on the world as we know. The ability to customize to the needs and the requirements of the customer, or the patient in this case. So, that's all very nice. What are the challenges we face? I want to pick on one specifically, and one that cities, societies, governments, and individuals can address. And it's education. What do I mean by education? The new Industry 4.0 requires a different set of skills. It requires science, technology, engineering, mathematical skills. Those are the key skills to be able to work in an industry of flexibility, of rapid design. It's the ability to utilize data as it exists and turn it into products. Many countries, many societies have very significant shortages in the number of qualified people coming through our schools and universities with a STEM education background. So if there's one thing that we can fix, it's to inspire people to start getting excited by science and technology. Now, I'm a hypocrite. I'm an accountant, and I went the wrong route. And I came back into 3D printing very late in my professional life. So don't look at me, look at the example that I want to set for my kids and for other kids. These skills are critical, and everyone has an objective to work on them. Now, one practical thing, you can see here a MakerBot printer, and I put it here by deliberate design. All think back to the classrooms you were in, or actually this lecture. Statistics show that 10% of what you hear, you remember. If I get 12% from this audience, I've probably done well. If you feel and touch what you're making, that statistic goes up to 90%. So if we educate our children not just at university, but in school, by touching and feeling and experiencing technology, they'll be much better placed to take up those careers. There'll be much more energy and excitement. So we need to fill that vacuum of a lack of skills quickly to really take advantage of it. And those societies, those cities, those governments, those cultures that embrace this will be the ones that are probably successful in Industry 4.0. The other thing it needs, and I'll end on this, is you don't just install a 3D printer to be successful in the new world. There's an ecosystem. You need software. You need design skills. You need education. You need consulting ability. You need materials. You need brain power. For Industry 4.0 to become real, we need to stop thinking of hardware and hardware on its own. We need to think about the ecosystem and the environment around which businesses, whether they're the Airbuses or they're the small to medium businesses, the skills and the ecosystem they need to be able to make the development of their products successful. That's why we're investing very heavily, not just in the hardware, but in the materials and the software. And you've heard many talks from other companies doing the same. But it's not just about us, it's about the ecosystem of the industry that needs to develop. And finally, I want to go back to the first message. This is a rocket made by United Launch Alliance, where some of our plastic, thermoplastic parts are part of the launch critical pieces. This is an unbelievable opportunity. It's an opportunity, and that's why I'm so passionate about it and left the world I previously lived in. This is an opportunity to revolutionize the things we made across an enormously broad spectrum of products and applications, some of which are ready today, some of which will take more time and development. But that's the industry we're in. I hope everyone enjoys the journey. Thank you for your time.